Hi there, my name is Peter Marshall and welcome to this talk entitled Plan Your Druid Table Data Sources. These tips and tricks talks have been created by us here at Imply to share our experience with those of you who may just be starting out with Druid. And if you have any questions, don't forget, register on Druid Forum and we'll meet you there. 4 parts to this talk. We're going to look at what a table data source really is, what you can do with them, run through some examples, and then give you some signposts for further information. Let's just start with some really obvious things. A table is created in Druid by running an ingestion job. Now that could be a single batch request, or it could be an ongoing number of tasks that are supervised, and that's for streaming sources like Kafka or Kinesis. Underneath, each table is made up of a ton of segments, with each segment being part of a greater timeline of data. What you may not know is that Druid has lots of types of data source that you can use in a query. There's tables, which is what we're looking at today, but there's also lookups, unions, inlines, queries, and joins. There's much more about those in the documentation. So here's our first nugget. Cluster resources for ingestion are tied very closely to each table data source. That means your control over what is running when is also at the table level. So you might need to think about what you do in the larger ecosystem around maintenance, for example. And if you ever need to set an affinity for ingestion tasks, you also do this on a table level. Next, these segments for this table all live together in deep storage, and the authorization rules in Druid, the rules that grant access to one or other table, are also here. If you need to measure capacity or maybe manage or secure some datasets differently, think about what table your data goes into. And if you need to lock down particular datasets logically rather than using some kind of application logic, also separate at the table level. The schema for the table is also set inside each individual ingestion job and is actually stored inside each segment. That allows for schema development over time. And it's also where you specify a level of summarization on ingestion roll-up, not just to minimize storage waste, but critically to minimize the segment scan time and make your queries super fast. There is nothing to stop you from ingesting from the same source and creating multiple tables with different levels of roll-up, even different schemas. I could have a narrow table that's got a very specific set of dimensions, and then a summary table that's maybe got an hourly roll-up. What this does is to shrink the segment size. It reduces the segment scan time, and it could make these tables way faster than my big, huge, full import. Remember, the aim for you here in Druid is to make queries that come back in under half a second. And maybe that'll turn out to be using your summary table, while this other one, everyone accepts may be a bit slower, but it has all the data in it and the entire timeline. Speaking of focusing tables on the end user, maybe you'll have another table, but this one will be filtered and it will only show data that in this instance our friend Brian cares about. Don't forget, each one of these will need their own ingestion resources, and I also add work in keeping control over the ingestion tasks that are running for my admin team. An interesting feature to remember in Druid when it comes to schema, roll-up, transforms and filtering is that you can rework your existing data in a Druid table. That could be what's called a reindex job, or it could be a compaction. It's important to look at the docs to see what features are available in each type of ingestion task. A common scenario is to do further roll-up on the data as it gets older. If you've used a time series database, you'll be familiar with this concept of decreasing the granularity over time. Take a look at reindexing for that. Now let's talk about retention. The actual segments that will be available in the cluster are controlled by load and drop rules. only the periods of time that you set up in those rules will be available for query. So another consideration you have is how long this data is going to live for. If you have some data that has a legal retention period of say 6 months, but another that has a period of 7 years, you may need to think about different tables. One with a drop rule that only shows 6 months, another with a drop rule that only allows for 7 years. Together with security, retention is often something you can't get around. So do speak to your compliance teams and find out what these policy requirements are sooner rather than later. Also part of the load rules are the replication factors. If you therefore have one table that is really critical to your business, or one where you want to maximize the chances of parallelization at query time by having lots of copies of segments throughout your cluster, you need to configure that at the table level. You can read more about what you can do around retention and replication on the docs page, and there's also a tutorial in the docs that you can follow to try it out. Now for a moment, imagine that my Wikipedia table that I've been talking about all this time, it turns out, only covers data for Anna. And I need to actually show both the Brian and the Anna data together. Because my schema matches across these table data sources, I could actually use a union all operator at query time. Now to the end user, they have no idea I'm actually querying multiple tables. When you do a query with union all, Druid uses another type of data source in the queries. It's called a union data source, and it's important that you check out the docs to learn more about that. Something else that's part of the way we set up ingestion is sub-partitioning. That enables us to cluster our data by saying how it's set up underneath each time partition. When you have a particular UI that is always filtering by a particular dimension, perhaps it's a multi-tenant UI, or you're doing something in IoT where you want to filter by particular device geography or type, for example, sub-partitioning is really important. By extension then, you may find yourself needing to have different partitioning schemes in different tables for different parts of your application. Maybe you'll want a table for your security operations center with just 1 week's worth of data partitioned in a particular way that your long-term security analytics team doesn't necessarily need. There's an awesome page on multi-tenancy, and I really do recommend taking a read on that. Now for tiering. Tiering is a part of the way you set up load rules. You tell the coordinator process to push certain periods on your timeline onto different data processes in your cluster. It's kind of like affinity, but for the segments themselves. Tiering is an awesome way of saving money and keeping users happy. Maybe the latest stuff will be on a super fast i3-256 quadruple X large, but the older stuff will live in buckets under your desk. Tiering rules are table specific. They don't apply across tables. What I mean by that is that you can't actually have 60 days of data from one table and the next 180 in another table and then distribute that via tiering. To do that, you'd apply retention rules, and you could use something like that union operator. Also per table are rules for automatic compaction. Automatic compaction is like a defrag task, and it will consolidate and generally hug your segments. It is configured per table data source, and that configuration includes settings for how much of the data will be compacted and what the compaction configuration is that you want. If you're doing streaming ingestion, the likelihood is that you need to do automatic compaction for late arriving and out of order data. On batch ingestion, it may not turn out to be so much of a priority. Take a look at this docs page on AutoCompaction and the related compaction task documentation, not just to read about what it all is all about, but also to read what you can do automatically to your data using compaction type tasks. And finally, please try and avoid doing this. Generally, it's a good idea to keep the number of tables in your cluster below 100. It's not just the ingestion resources that you have to scale up, it also resources and the coordinator as the things it has to manage for you increases, from data distribution and balance to compaction. If you get to this point, it's probably a good idea thinking about splitting data up within a single table rather than creating a new one. If you have any questions about what you've seen here, register on Druid Forum, raise a question, visit learn.imply.io for Druid related courses, and with me, please do say thank you to the developers behind Apache Druid by putting a star on the Apache Druid GitHub repo. Thank you.